What is a function? A function is a specific rule between two sets. You start with an input taken from one set, and the function assigns it exactly one output in some other set. This mapping creates a whole bunch of input and output pairs. All of your inputs live here, and all of its outputs can be found here. You know how there are clothing factories with like a whole bunch of machines? Let's imagine that you have one machine, and its main function is to take some string and make it into a shirt. Let's say we have 5 different strings: red, blue, yellow, purple, and orange. If I want a blue shirt, I have to give it a blue string. Red string should give me a red shirt, and so on. Now, as you can see from here, we expect the machine to give us a shirt that is the same color as the string. We know that this is a function because it creates an input and output pair, and it follows that relation every time. This machine is guaranteed to work if I put these strings in. But the moment I start inputting things that this function is not designed to handle, it may work. Like, I could still get this green shirt even though I did not specify that this green string is part of my set of inputs. However, this function is not guaranteed to work every time. Could I really put anything in there? Anything? Alright, back to math. Functions can be represented using equations. When we want to properly define a function, we need to make sure it answers some questions. For example, 1, where does the input come from, and what should we name it? 2, what is the name of the function? Is it a symbol, image, a letter? 3, what is the function doing to the input? Is it perhaps squaring it, multiplying it by a coefficient? In other words, what is the rule that it's doing to get the output? And 4, which set can we expect the output to be inside? Like, if we were to take a look at this equation right here, it's not explicitly clear what these letters are. For instance, what is x? From which set does it come from? Is x a number? A cat? If it's a cat, then what is cat squared? But wait, can we really be sure that f is the function's name? Or is it just some variable? If this is a function, where does the output go? Right now, they're just some meaningless random letters. See what I mean? We had to define things a little bit better than that so that there is no ambiguity. Let's fix it with an example. We define f to be a function from the set of real numbers to the set of real numbers. The function takes each x value from this set right here and assigns it a unique number from this set. It does this by following the procedure outlined over here. For example, let x be 5. Since 5 is a real number, squaring it yields 25, and it can be found over here. There are some special facts about these two sets. The set from which your inputs come is called the domain, and the set where outputs can be found is called the codomain. In this case, I chose my domain and codomain to be the set of real numbers. However, I could change this. For example, I could make the domain the set of integers and keep the codomain as such, or make this domain contain 2 numbers and the codomain be the set of integers. Now that we have defined the domain and codomain, an interesting question arises. Is it possible to capture every point in the codomain? If the domain just contains 2 numbers, what can this function actually produce? It can produce a 1 and a 4. However, it never produces 2 or 3, and all the integers in this set. This introduces a well-known concept known as the range. But what exactly is range? The range, or the image by what some people might call it, it's also going to be another set, except this set contains all of the outputs your function can actually give you. It is similar to the codomain because they also contain the same outputs, but they are completely different sets. Your function's outputs are in both the range and the codomain, except that the difference lies in whether the codomain may or may not contain extra elements. As in this example, we were unable to obtain the remaining integers, except for these 2. Therefore, the range is just 1 and 4 for this particular function. It's like saying that this function is only going to hit this, and this value right here. And unfortunately, it's not going to be able to hit these other values here because it is out of my range. Okay, let's do some quick examples to understand this better. Suppose you have a function g from 0 to infinity to the set of real numbers, where the rule says that g of r is equal to the square root of r. And in this case, we're making r to be the input from the domain, not x. The codomain is a set of real numbers, but the actual range is from 0 to infinity. This is because the function cannot give us negative values. It's impossible. The square root function only gives us non-negative values. So we set the domain to be 0 to infinity to reflect this. Another one, let r be a function from negative infinity to 0, union 0 to infinity. That just means that we are not including 0 in the set. So from this domain all the way to the set of real numbers. The rule in this case is r of z is equal to 1 over z, where z is the input from the domain. The codomain is a set of reals, but the actual range is any number except 0. This is because no input can give us an output of 0. Again, this is a subset of the codomain. A couple of last things. A function must never give two outputs. That is not a function. We always want one output for each input. That is why circles are not functions, because as you can see here, I am getting two outputs from one input. Secondly, using the same rule does not mean they are the same function. I can define f to be from naturals to naturals and g to be reals to reals. Just because we square both of them does not mean f and g are the same function. They are completely different, and you can see this visually too. And that is about it. Here's a quick summary of all the things we've talked about in this video.